In this series of videos, we're going to learn about the most common types of chemical reactions, as well as how to figure out the product of a chemical reaction if we know what the reactants are, and balance them to make sure that we have an equal amount of reactants and products. Our starting reaction type are what we call the synthesis reactions, which are reactions that take two or more elements as opposed to compounds and then combine those elements or compounds together in order to make a larger compound. So if we take a look at this synthesis reaction, we have magnesium reacting with oxygen, which is going to give us magnesium oxide. So the way that we find out the chemical formula, remember when we talk about ionic compounds, is we know that magnesium is going to have a charge of +2 when it forms an ion because it loses 2 electrons, while oxygen is going to have a charge of -2 when it becomes an ion because it's going to gain 2 electrons. +2 minus 2 is 0, which means that we only need one of each atom, so our formula is going to be magnesium oxide. However, we can see a different type of synthesis reaction, and this is where we take two small compounds that do the same sort of thing as the elements in the previous reaction. The two compounds come together and combine in order to make a larger compound. So in this case, we have an acid called carbonic acid, H2CO3, and we can see that if we break this down into two compounds, one of those compounds would be water, H2O, and the other compound would be carbon dioxide. So in either case, we can write the general formula for a synthesis reaction as being A plus B, where A and B are either two reactants or two small compounds that combine in order to give us AB, which is the larger compound, or simply the compound made from the two elements. Now, if we do a synthesis reaction backward, we would be doing what we call a decomposition reaction. For example, we know that if we have aluminum oxide, the two elements that aluminum oxide will break down to are aluminum metal and oxygen, and we would write O2 to signify that this is oxygen gas. So we have one compound in this case because instead of starting with two reactants, we're taking the compound from a synthesis reaction, and that's going to be our reactant, and then that compound is going to break down in order to form two elements in this case. However, just like with the synthesis of carbonic acid that we saw, we can also have one large compound, such as, spelled compound wrong here, one large compound, such as copper 2 carbonate that we see here, that decomposes, again, decomposes just the scientific word for breaking down, in order to make two smaller compounds. So if we take a look at this reaction here, we can take copper 2 carbonate and break it down into carbon dioxide. There's C and 2 of the oxygens there, and what we would have left over is copper oxide. So we can see that instead of breaking copper 2 carbonate into two elements, we have it broken down into two smaller compounds. Now, in either case, the general formula that we can write here is, instead of starting with the elements A and B, we're going to start with AB as our reactant, and then AB is going to break down into A plus B, and we can use this general formula as a way to identify whether a reaction is a decomposition reaction. The next category of reactions are what we call replacement reactions, and we can see the main word in here is replace. You may often see that the word displacement is used instead, but the words displace and replace basically mean the same thing, where we have something that takes the place of something else. So this first type of replacement or displacement reaction is what we call a single displacement or single replacement reaction. So there are actually two of these that are slightly different. So we can see in the first one that we have zinc. So this is an element. We're going to call this A. And then we have hydrochloric acid, which is a compound. So we can consider this to be BC. Now, when we look at how a displacement or a replacement is going to work, we need to figure out whether zinc is going to replace the hydrogen or whether it's going to replace the chlorine. So we need to think of what kind of ion our A is going to form. So since zinc is a metal, if we check our periodic table, we can see that zinc has a charge of positive 2. So if we go back here, if we know that zinc has a positive charge, that means that it is going to replace whichever atom has the positive charge in our compound, which is going to be hydrogen, because we almost always write the positive charge first. And remember that chlorine is going to have a charge of -1. So that means that zinc and hydrogen are going to switch places or displace or replace each other, meaning that we're going to end up with zinc and chlorine bonded together and hydrogen on its own, but we write this as H2 because hydrogen forms a gas where it exists as two atoms together. Now, to figure out the formula for zinc chloride, remember that zinc has a charge of positive 2 as an ion, and chlorine has a charge of -1. So since we need two chlorines, because -1 times 2 is -2, that would give us a total negative charge of -2. Positive 2 minus 2 is 0, so our charge is balanced. So in summary, here we have a single metal in this case, but we're going to write cation because zinc forms a cation when it becomes a cation, which replaces the cation in an ionic compound. Now, in a more general way, we can write a single metal that replaces the metal within the ionic compound, but remember that it's not always a metal. It could be hydrogen, or it could be a positive polyatomic ion. So saying cation is the more correct way. Now, if we take a look at the next single displacement reaction here, we can see that our A is chlorine gas and our BC is KBr. Now, chlorine is different because, as we saw in the previous single displacement, our chlorine is going to form a negative charge, while potassium here is going to form a positive 1 charge as an ion, and Br is a halogen just like chlorine, so we see that it's going to form a negative charge. So in this case, it's the two nonmetals, because each of the nonmetals is going to form an anion, and the anion that is formed, the negatively charged ion, is going to replace the other anion in the ionic compound. So our two products that we would get are KCl, because we form a negative ion when Cl becomes part of an ionic compound, and then Br is going to be replaced. But because Br forms a diatomic compound, we would write it as Br2. So our general formula, regardless of what type of single displacement reaction, is going to be where we have an element A, and that element is going to replace either B or C. So in our first situation, A replaces B because zinc and hydrogen both form cations, so this would be AC plus B. Or in our second example here, where chlorine is the A and KBr is our BC, we could end up with ABC goes to BA plus C instead, if our element is an anion rather than a cation. Before we end this video, we can see that if we count the total number of atoms on the reactant side and the product side, I haven't actually made these equal, which is what we call balancing. In the next video, we're going to look at the other three types of chemical reactions, that being double displacement, neutralization, and combustion reactions. And in the third video after that, we're going to look at strategies about how to balance chemical reactions.